In last section or lecture, we have discussed about various commonly used material used for valve manufacturing or valve body construction. In this section, we will discuss in further detail these commonly used materials and what are the chemical elements that are used and what are the significance of them. So in the last section, we have studied a similar chart where we have divided the steel into four groups in carbon steel, high temperature steel, low temperature steel, and stainless steel. Within the carbon steel, you will get two categories, or rather, each of these groups are divided in two categories. One is for casting, and another is for forging. Casting and forgings are two different methods to make the material or to make the mechanical component. The manufacturing process wise, these two are different. One is casting and another is forging. Now, in case of the carbon steel, you can see that in the casting category, we have WCV and WCC, two grades of material, and the material specification that is being used in ASTM A216. So this is the specification that is being used, ASTM A216, and the grades of materials are commonly used are WCV and WCC. There are various other grades in the casting category of carbon steel, but these two are the most commonly used. And in the case of the forging, we have ASTM A105, and this is the standard name, and also the material name or the grade name is same, because in this particular standard there is only one grade, and everybody calls it with the name A105. In case of the high temperature steel, this is the steel which is mainly used when the temperature crosses 450 degrees centigrade. And in this case, we have two categories. One is casting and another is forging. In the case of the casting, the commonly used material is WC6 and WC9. And the ASTM standard that is being followed is A217. So in the later courses, we will discuss in detail each of these ASTM standard and also discuss the chemical composition of these particular items. So similarly, in case of forging, we have F11, F12, F22, F91, and F21. So here the standard or specification that is being followed is ASTM A182. Next comes the low temperature steel and ASTM specification A352. In this case, we have only casting, and we have two categories, LCB and LCC. And the next is the most important and widely used, the stainless steel. And stainless steel also, in this case, we have two categories. One is casting and another is forging. The casting standard is ASTM A351, and commonly used material are CF3, CF8, and CF3M and CF8M. Similarly, in case of forging, we have ASTM A182, the same ASTM standard that is being used for high temperature steel also. In this ASTM A182, there are lots and lots of materials, and we are only concerned about some material which are most commonly used. So these are 304, 316, 304L, and 316L. So in this particular slide, you can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So basically there are 20 different categories of steel, and these 20 categories of steel are most widely used in case of the valve manufacturing. So here we are not going, we are mainly concerned about the valve manufacturing and valve material selection. So if we know the characteristics of these 20 different type of steels, we can cover almost 90 to 95% of the valve industry. Rest 5%, there may be special cases and special arrangements. So we will also study that, but in later course of time. So by this time, if you are new to the valve design engineering and if you memorize this particular slide, this will be of great help to you. Okay, now initially, now each of the standard, there are these three standards. So each of the standard, what we need to learn, or in case of the particular material, suppose we know that this is WC6, this is the material name, and what else do we need to learn? Second is chemical element, what is the chemical composition of that particular material, what is the main item, that is main chemical items that is being used for manufacturing that particular material that we need to know, because the percentage of the chemical element determines the property of that particular material. And third is usage. So based on the chemical element and uh, that particular item's construction or the way it is being prepared, its usage depends, and we need to know the usage. We need to know where to use W66, where to use WC9, whether we would use WC9 or we will use W66. That we need to know. Or if we want, we need to know whether we want to use SS304 or SS316, or we want to use 304 or 304L. This all we need to learn. So slowly we will learn, and I hope in the course of 3-4 lectures you will be able to understand these things very clearly. So in the chemical element, as you can see, there is a chemical element. There are various material that is that constructs that particular material. So as we are dealing with the steel, for the valve manufacturing, the major component of the steel is iron. That is more than 16 to 16, more than 60 to 70% of material is steel, is iron. And the next most important element is nickel. And then there is chromium, there is molybdenum, there is manganese, and there is carbon. Basically, after iron, the carbon is most important, because when the carbon mixes with the iron, then only the steel is being made. And additional of this, another 4 or 5 chemical elements makes its usage more more prominent. So we will discuss benefits of adding this particular elements, this particular chemical elements one by one, and this will clear your doubt. And in the future, if you see any new element and you know the chemical component of chemical components of that particular material, then you can easily tell that this will be the probable property of this particular material. This will really help you in selection of the material, not only in the case of the control valve, but in case of other materials also. So let's discuss about these various chemical elements one by one. So first is iron. This is the most commonly found chemical element on Earth. Atomic number is 26 and denoted by the symbol Fe. And iron is basically a very soft material. When it is mixed with carbon in the percentage 0.02 to 2%, steel is being produced, which is a harder material. So if we increase the carbon component to more than 2%, another type of iron is being produced that is known as the cast iron. So this cast iron is completely different thing, and cast iron is brittle because carbon concentration is high. You can see the cast iron usage in making various cooking utensils, and when this cooking utensil like the cast iron frying pan or etc., when they falls on the ground, they breaks or cracks appears on it. So there is a brittleness in the cast iron. The second most important component that is being used to make the steel is obviously carbon. Carbon is also the fourth most abundant material on Earth. When the carbon is mixed with iron in proper quantity, is makes the steel, and it is the carbon that makes the steel stronger. Iron is basically soft material, so when the carbon is added to it, it becomes a steel, and its mechanical strength increases. So within the range 0.02 to 2%, as you increase the carbon content, the mechanical strength of steel increases. So if you compare two material, if in one material the carbon content is high, you can definitely tell that that particular material has more strength, more mechanical strength. So we will discuss this with the example when we will discuss various type of steel like SS316 and SS304. Next important material is nickel. So nickel is a chemical element with the symbol Ni and atomic number 28. It is a silvery white lustrous metal with a slight golden tinge. Nickels belong to the transition metals, and it is hard and ductile. More than 2/3 of the global nickel production is used to produce the stainless steel. As an alloying element, nickel enhances its important properties such as formability, weldability, and ductility, while increasing the corrosion resistance in certain applications. The alloying element that makes the steel stainless is chromium. However, it is the addition of the nickel that enables the stainless steel to become much versatile alloy. In addition to their inherent corrosion resistance, nickel-containing stainless steels are easy to form and weld. They remain ductile at very low temperature and yet can be used for high temperature applications. In fact, nickel is so important that nickel containing grades make up to 75% of stainless steel production. Based off these types are 304, which is 8% nickel, and SS316, where the nickel percentage is around 11%. So basically, the nickel makes the steel more versatile, its weldability, formability, and corrosion resistance increases. Next is chromium. Chromium is a chemical element with a symbol Cr and atomic number 24. It is a steely, gray, lustrous, hard, and brittle transition metal. Chromium is the main additive in the stainless steel, to which it adds anti-corrosive properties. Chromium is the main additive in the stainless steel, to which it adds anti-corrosive properties. Chromium metal is one of the high value for its high corrosion resistance and hardness. The major development in steel production was the discovery of that steel could be made highly resistant to corrosion and discoloration by adding metallic chromium to form the stainless steel. So chromium and the nickel, these two elements are mainly added with the stainless steel category, and these two adds real shine to this metal. So chromium is mainly makes the steel stainless, and the nickel is the thing that makes it very easy to use. Its formability, weldability, everything increases with the nickel percentage. Another important material is molybdenum. Molybdenum is denoted by the symbol Mo, and it has the atomic number 42. Molybdenum is also valued in steel alloys for its high corrosion resistance and weldability. Molybdenum contributes corrosion resistance to type 300 stainless steels, specifically type 316. The addition of 1% to 2% of molybdenum to ferrite stainless steels also significantly increases the corrosion resistance and elevated temperature strength. So molybdenum is particularly important in case of the stainless steel because it increases the corrosion resistance of steel, particularly in case of the high temperature. So chromium is there. Chromium already increases its stainless or corrosion resistance, but if we add molybdenum to it, the corrosion resistance increases further. So this is the main difference between the two grades. You can see that CF3 and CF3M. So these are two grades. M is for molybdenum. So when the molybdenum is added to it, CF3, it becomes CF3M. So the CF3M has higher corrosion resistance compared to the CF3. So when it is to be used in further corrosive environment, molybdenum is used. Another important element is manganese. Manganese is a chemical element with the symbol Mn and atomic number 25. It is a hard, brittle, and silvery metal often found in minerals in combination with iron. Manganese is a transition metal with a multifaceted array of industrial alloy uses, particularly in stainless steels. It improves the strength, workability, and resistance to wear. Manganese is used in carbon steel also, and it increases the resistance to wear mainly, and also improves the strength and workability. So we have learned about iron, carbon, nickel, chromium, molybdenum, and manganese. These are the main 6 materials that are being used to make the stainless steels or steel, carbon steel, high temperature steel, and low temperature steel. So we know now know the properties of this material, and so depending on the various percentage of these materials, the grades vary. So now if any random material is given to us and the chemical component is also told to us, then we can have an idea about what will be the mechanical strength, what will be the resistance to corrosion of that particular material that we will be able to tell.